Hello, my friends, user of internet. I would like to introduce you the module Galileo that I had the opportunity to follow during the last meeting of free money, which happened in Toulouse. It was the 8th time we had a free money meeting. And to do that, I will act as if I was introducing that module to one of my friends, and in case they think that he doesn't get, he is allowed to ask questions to have more precision about that. The module will present the evolution of the account of three different individual 1, individual 2, individual 3. So randomly I gave 1,000 of money to the first person and 9,000 to the third one. The second has 5,000. This is not random, it's the average of the account. It's to make it average. You will understand later why I did that. And here you can see the monetary mass of these three individuals of their account divided by the number of people, which is the same than if it was an average. That's why you have the same for E2 and this. You can see that it's the sum of the three divided by 3 because there are three individuals. And here I calculated a universal dividend that I would give to, not me, that these three individuals, in the case they want to use a free money on their economical system, they agree to use a universal dividend system, and the universal dividend is the 10% of this monetary mass divided by the number of individuals. This 10%, if you are wondering where it comes from, I invite you to read the relative theory of money, which will explain where it comes from. But it's basically a factor linked to the lifetime of humans. So we can see that the second year, individual 2 has what he got the first year plus the universal dividend. Same for his co-citizen of the economic zone. And here are the years passing for a lifetime, around a lifetime, 80 years, and we can see the evolution of these accounts in the condition that they don't exchange in between them, or if this exchange are uniform, are the same for everybody. Let's say that maybe during the first year, E1 is going to to sell something for 500, E2 is going to sell something to E3 for 500, and E3 would sell something to E1 for 500. Then in that case, we have also the same evolution of accounts. And
so you mean this in this case, we are not talking about exchanging money. It's just pure universal dividend that is transferred to each person's account every year, and that's it.
Yeah, it either that, either they are exchanging, but they are exchanging the same thing.
Okay.
500 each to each one.
Okay.
E1 to E2 500, E2 to E3 500, E3 to E1 500. Then in that case, if they do that every year, the 500 being able to change also, it could be 600 or 700.
Yeah.
But if it's uniform, it's the same, then we have the same evolution of the account of the three individuals.
Yeah.
And if we look at the graph, the curve of these three account in quantitative reference, in quantitative, we can see that curve. At the beginning, we can see that the three accounts are a little bit different, but at the end they disappear in one, like if they were one, because the difference is very small between the accounts. And that we will see it in a much more obvious way if we observe this same account in a relative way. To observe that in relative, we take each account and we divide it by the value of the universal dividend. So it's the same economic zone, the same evolution of account, but in another referential with a relative point of view. So in that case, we will see that, of course, universal dividend becomes 1, and we can observe something very quickly, that E2 get the same numbers all the way, and the other one are changing, but it doesn't seem to change much. Yeah.
I would recommend you to, if you want to show, try to do this.
Okay. And if we look at these three curves in a relative point of view, so as I say, E2 is at the average, and it will not move for average. And the E1, who had an account on his account less than the average, as you remember, he had only 1,000, which is, when you divide by the universal dividend, get 2, which is lower than the average. Then the tendency of its curve is to join the average, to merge with the average, and the E3, who had an account which was higher than the average, has also a curve which has a tendency to merge with the average. And here we see at the end of the 80 years, again, we see that the three curves are very much merged, which was the same than here. We couldn't see any difference anymore between the three curves. Now we can also observe this again, the same economic zone, but with another point of view again. This point of view is that simply I put the average equal to 0. So what I did is that I divided each account, subtract each account by the average of the three accounts. So you can see every time I divide the account by the average, and it gives another view of the same economic zone, and which is very maybe surprising at the first time, because it seems that it doesn't evolve at all, and they are not moving, not joining each other. It seems that nothing is happening. For people who are used to local exchange system, using local money based on time of working, they will be they won't be surprised to see this kind of graphic. It's quite understandable. This means that the E3 has 4,000 unit that he can use, more than the average of people, and E1 had 4,000 units less than the average that he can use. And because the and this doesn't change even with the addition of the universal division. This difference is not changing. It was 4,000 at the beginning, it is 4,000 at the end too. But this quantity of 4,000 becomes relatively small here than here. At the beginning, the relative quantity of 4,000 is huge, but with time, this quantity of 4,000 becomes very small compared to the amount of the monetary masses. We can neglect it. When we come close to 80 years, it becomes very, very small. And again, the same idea, the sum or the average put to 0, but in relative. It gives the same curve we see than previously when we have a relative point of view. The accounts which are far from the average have a tendency to merge with the average with time. That was the first exercise of the module Galileo. Then we had an exercise to see if it was possible to simulate the same evolution of economy using a tax system. So we have been given that tax and it works. I put directly in E1, E2 and E3 their relative amount they had here, 2, 10 and 18, 2, 10 and 18. And if I calculate the tax for E1, tax for E2 and tax for E3, and we sum these three tax and we divide it by 3, then the next year E1 will see the amount of his account minus the tax plus the return of the tax, the giving back of the tax, and the same for E2 and for E3. And not surprisingly, because that was the purpose, we have exactly the same curves. So it is possible to have the same result as using a universal dividend by a tax system. But the question is, what is easier? Is it easier to create a universal dividend, to co-create a universal dividend for each individual having the right to co-create the money through a universal dividend? Or is it easier to have a centralized system which is taxing every account of every individual and redistributing, which is going to redistribute these taxes among the account? I let you choose what sounds easier for you. Then the next exercise was to simulate exchanges between individuals which are not the same. So for example, here E1 is selling to E3 for 2,000 units of money, of their money. So E1 see his account having 2,000 added, and E3 has 2,000 less. And again here I made another exchange of 5,000 between E1 and E3. And here you have the same economical zone with the same exchange in relative, and here again the same in a point of view where the average is equal to 0. And it gives these three curves. So in quantitative we don't even see the exchange because they were at the year 5 and 20. So 5 and 20 we can't even see the exchange because the axe is very huge. Sorry. But in relative we can see here the exchange the first time for 2,000 and here for 5,000. Again, if that is bigger than here, even though here it's 2,000 and here it's 5,000, it's because we are in relative. So 2,000 at that time was a big amount compared to the monetary mass, but here 5,000 is small compared to the monetary mass. And we can see another interesting thing is that we can see that even after the exchange, the tendency is the same. After the exchange, the tendency keep going, merging to the average. And if we look with the point of view with the average equal to 0, then after the first exchange of 2,000 and the second exchange of 5,000, then E1 now has 3,000 units more than the average and can use it to make exchange, and E3 has 3,000 units less than the average. But again, you have to remember that these 3,000 are very small compared to the monetary mass at that time. The fourth exercise was to simulate the lifetime of 20 individuals. We start with 10 individuals with random account, and the first one die after 8 years, the 11th individual born, and E2 is going to die after 16 years, E12 is going to born after 16 years. So we can see here the dead people in red, the living people in white, and the not yet alive people in green. Of course, when E1 die, his account is blocked. There is no more universal dividend added, so it's stay the same, and the same for every time someone dies. I have it here in quantitative, and here I have done the same in relative. And if we look at the curve in relative, because in quantitative it will just be again the same than here, one curve where we won't see any difference between them, but here is much more interesting because we can see each curve having the same tendency, merging to the average before their death, and also for one who are going to born, who start at 0, they also have a tendency to merge with the average. And I have done the same graph, but with I decided that E2, when he dies, he decided to give his money to E6, just to to simulate that, which is possible. It's a political choice to decide that or not, but it doesn't change the tendency of the curve, which is always going to the average. The last exercise was to have a look at one value in the economy. I decided to choose silver, which in French is argent, and I check the value of silver in dollar over the time. I check the value of euro and dollar over the time to have also the value of silver in euro, and I check the value of what we in France have, which is called RCRSA, which is for people who are not working, are looking for a job. During the time they are looking for a job, the government is giving them money, and this is the amount of euro that they have per month. This column is the monetary mass of the Eurozone, and here I have the evolution of the price of the meter square in Paris over the time. Then all the column you have here, equivalent 2005, equivalent 2005. It's just that I did a little bit of work on the number to have all these values merging in 2005 to be able to compare the curve on the same graphic. So I'm not interested by the value of these numbers, just by the form of the curves that you will see here. As you can see, in 2005 all the curves have the same value, but you should not pay attention to the value of the curves, just their form.
There is no point why they all meet at this point in 2005.
Why it was 2005?
There is no reason that why they meet at that specific point.
No, I chose that randomly because it was in the middle of my curve, of my time, of my study of time.
Okay. So you just try to shift the curves with respect to the screen to make it visibly
understandable.
Yeah,
exactly. So we can see, for example, that the value of silver in euro, which is the blue curve, it has the same form, the same shape than the value of silver in RMI RSA or in monetary mass. They have the same shape. There is some differences. For example, here here it's increasing, but here it's decreasing. And we can see, for example, that the meter square, the green one, has a shift in time. There is a difference in time. It doesn't. There is like if it was a consequences on one to the other one. But if we look at the shape of gold, there is also something interesting, that it's obvious that in euro there is a peak in 2012. It's where silver has the highest value in euro, but the time where silver has the highest value in gold is 2006. in 2012, it's lower than in 2006. So this graph is just to understand that the value of one thing is depending on the point of view, on with which value you are measuring that other value. If you measure the value of silver by euro, or if you measure the value of silver by gold, you don't get the same result. So values are all relative one to the other. Thank you very much for your attention. I hope you find it clear enough and you will want to know more about free money and the relative theory of money that I invite you to find on internet and read carefully. Goodbye.